Hello everybody and welcome back to the free online woodworking school where we aim to take your woodworking skills to the next level. In today's video I'm going to be showing you the machine/power tool method to cut the groove out for the shelf within the cabinet and also the rebate at the back of the cabinet to accept the back panel as well. Let's get going. Right, so this particular part of the project I've decided to split into two separate videos. The first one being focused on machine and power tool methods, the second one being focused on hand tool methods. So if you're watching this on my free online woodworking school, just scroll down on the page and you'll find the hand tool method there. But for this video, where we're focusing on the machine and power tool method, you are going to be needing a router that is able to accept a guide bush, and ideally you're going to be needing a router table as well. Secondly, you're going to be needing to make this jig right in front of me here. And if you want plans for this jig, they are included in the plans for the cabinet, which is available from my website, matteslea.com. So just to talk you through how this jig was made and the important parts of it and what it's actually meant to do. So within the cabinet, you can see I've roughly scribbled in an area where that groove needs to go, much like I did in the previous episode for when we were marking out the mortises on the inside of these. I just do a quick scribble mark there so I can confirm that that is where I'm going to be cutting, as opposed to here, or God forbid, on the outside of the cabinet. So that line is going to be where we're cutting. And this jig is made to slide the component under like that and butt up against a component on the side here, and also butt up against the middle like that. What this will result in is once the router goes in and cuts a groove, it's actually going to prevent the cutter from going all the way through the front of the cabinet, and it's going to give us a stopped groove within here. And the way this is done is by the use of a guide bush attached to the bottom of the router. And this needs to be a very snug fit within that channel. Like, that's pretty damn difficult to move in there. There's going to be no lateral movement in that whatsoever. And although this jig looks somewhat complicated, there's actually only 2 or 3 bits that need to be absolutely spot on. The rest of it is just for like clamping area and butting components up against and, you know, little things like that. The main parts that you need to get absolutely spot on are firstly the distance for the guide bush to fit in here, because you really don't want any wobble or side to side movement in there, because a zigzagged groove would not be ideal. And secondly, this component here needs to be absolutely bang on parallel, because this is going to be what dictates the height of the groove from the bottom of the cabinet, and that the 2 grooves on either side of the cabinet are in line with one another. It's really important that that's parallel. Now, I don't have a table saw in this workshop, as many of you know, but what I do have is a bandsaw and a planer thicknesser. So I chose to make this from birch plywood because it meant that I could cut it on the bandsaw and then stick it up on end through the thicknesser in order to get both edges completely parallel with one another. Of course, there are many ways to do it, but that width is listed on the plans. And if you want the drawer to be sized correctly, that distance is going to be what you need. If we flip it over, you can see exactly how it works. So if I do that, then the cabinet literally just slots into that corner there. The reason there's 2 sections for this is because if I was to do the other part of the cabinet on here, you can see that the face side is going off the edge here, which means that if I was to use the exact same side of this jig to cut the groove, I would end up cutting the groove through the front of the cabinet and the stop would be at the back, which is obviously not what we want. So by making 2 sides to the cabinet, it means that I can then come in from the back like this, and then once the guide bush hits this stop here, then that is going to produce our stopped groove on the front of the cabinet. So effectively, if I was to lay this flat, let's see, so we've got the front of the cabinet here. We obviously don't want to blast through that. So that needs to be lined up with the stop, and there is our line. So that will go under like this. And then we'll just confirm it on this one. There's the front of the cabinet. So we want that to be up against the stop, but we obviously want to be cutting on the inside, and there's that line there. So up in there, and these will get clamped down individually. You don't cut them simultaneously, but you can see roughly how that jig works now. The guide bush goes in there, we set the depth on the router bit, and you cut a groove from the back of the cabinet, and then it gets stopped before it blasts through the front. Take it out, pop it in here, go through this way, and it stops before we get to the front edge of the cabinet. It looks pretty complicated, but there's not really a whole lot to this, to be honest. These stops on the bottom are just super glued in place. These are super glued in place. They could be screwed as well. These spacers that create the slots for the guide bush have been dominoed in place, but you could also biscuit them, or they could even be butt jointed if you were careful not to have any slippage between the various components. There's so many ways of doing it. Doesn't need to be overcomplicated, but as I said, plans for this are included in the plans for the cabinet. So just to talk you through through the setup of everything I've got here. I'm using the Bosch GMF 1600 at the moment. What's special about this router is that this motor unit can come out of the plunge base and it can go into a fixed base under a router table. So it's ideal for this situation. I'm not going to talk about it much, but I have already done a review for this tool if you are interested in getting it. That'll be linked in the supporting resources below. But just to go through the setup of this, I've got this little adapter here, which is what's going to accept my guide bush. And a guide bush is nothing more than a sort of bushing, essentially, that sticks out from the bottom of the router and allows it to locate, in this case, within that slot that I'd cut. Now I've got an adapter that fits this, and then that gets fitted into this thingy, but all brands are different when it comes to this. What I would strongly advise is getting a set of these. These are threaded guide bushes, and with the addition of an adapter, they will fit on pretty much any brand of router. They're really good, and I'll also link those in the description below. So we're using the 30mm one today. I'm just going to attach this to the inside of the plunge base. Like I said, all routing brands are different, but if you're working with a plunge base router, then there will almost certainly be guide bush attachments available for it. So if you're unsure how to attach one, just consult an instruction manual. So I've then got this little adapter which will fit within the base of this. And this adapter that I've just attached is what you need in order to accept these threaded guide bushes. So they come in two sections. You've got the guide bush itself. This is the 30mm diameter one. And then you've got the threaded nut on the back. So that will simply thread into your adapter, and then the threaded nut goes on the base. I'll just keep tightening it until it gets nice and snug in there. There it is. Because the advantage to this set is that if you have a variety of router brands in your workshop, or you're planning on upgrading soon, one of the annoying things would be if you had a full set of guide bushes to fit your particular branded router, but then when you buy the new router, those guide bushes no longer fit. Whereas if you had this set, all you need to do is buy a new adapter to fit your new router, and then all of these will fit within that new adapter. So it's a really good set, and I mean, it looks pretty cool as well, would you not agree? And I've already put my 10mm cutter into the motor, so then that just simply drops into the base. There it is. And then we attach the extraction to the back of it. So then just to confirm everything again, we've got the groove going through the back and then stopping before it hits the front. There's the front edge as indicated by the face edge. So that will go in here, and then that butts up right into the corner against this component and this component. And I'm actually going to put a spacer under the back as well, just to ensure that the jig stays level. Clamp goes onto it. Careful not to get too close to the groove, or else you're not going to be able to fit the router past the clamp. Right, there we go. I'm happy that this is securely clamped in place. That is not moving whatsoever. So there's our channel. I can just about see my rough pencil line there, and the guide bush is going to stop against that backstop. Right, so then on goes the router. Guide bush will slot into the groove, and now there is no sideways movement on that whatsoever. It can only move back and forth. So the first thing we're going to do, and by the way, the machine is still unplugged at this point, we are going to plunge the cutter to hit the wood below. So I've got a lock on the back here that I can just plunge down and make sure the cutter actually hits the wood. In this case, I think this stop hit the wood before the cutter did. So I'm just going to loosen that off and then re-plunge. Yeah, still got further to go. There we go. So that's definitely hit wood, and I can confirm that by just looking through this gap here and seeing that, yeah, indeed the cutter is resting on the surface below. Now I want this groove to be 8mm deep. Remember, the cutter is going to cut it 10mm wide, but we've got full control of how far down we want that cutter to go. In order to achieve an 8mm depth of cut, we can use this scale here. And when you use this, what you'll notice is when you lift it up, the reading on here moves with the stop at the bottom. And you've also got a turret on the bottom here that you can spin round to give you different stops as the router plunges. So we're going to set it to probably the second one down, I reckon. There seems to be about a 4mm step between the two of them. So the rod is bottomed out on that second step. And what we're going to do is set this scale to 0, because with enough force that is able to move independently on the rod. It's a friction fit so that when you lift them together they will move in unison. So pop that onto 0, and for demonstration purposes I'm going to lock that in place. Now, because that rod is fixed to the plunge mechanism on this router, you can see that by the time I plunge this down and this cutter hits the wood, it's also hit the turret as well. So effectively we've set this depth to the surface of the wood, i.e. 0. If we want to go below the surface of that wood, let's say to 8mm, what you do is you lift this rod up to where that reading says 8mm. Now, the gap between the bottom of that rod and the turret that we set at 0 is 8mm. So effectively, if that wood wasn't in the way below, because remember that's what this cutter's bottoming out on, once that router bit starts spinning and it's able to cut into that wood, it's going to be able to travel that further 8mm between the depth stop and the turret. And I can demonstrate this by moving the router bit off the wood below. So you can see here, it's not bottoming out on that rod, not bottoming out, but by the time I get all the way here to where the cabinet is no longer below it, the rod's bottomed out. And I can confirm that by looking underneath here, that indeed when I turn this on, it's going to be cutting into the cabinet. Now, although this router could probably do it, ideally you don't really want to be doing 8mm in one cut, because the router bit will start screaming at you and you won't get a brilliant finish from it. And that's where this turret system comes in. If I just bring the cutter up so that it's no longer touching the wood or anything below it, what I can do is move this turret around to this higher setting so that when I place this above the wood and plunge it in, so we've hit the wood, when this starts spinning and it starts cutting, the first distance it's going to cover is about 4mm roughly. Let's say that's what the gap is between the rod and the turret. After we've done that pass, we can then spin the turret around to that second stop, which is where we set the 8mm depth of cut to, and we'll plunge it down to that setting, therefore doing the full depth of the cut but in two separate passes. And that's the advantage of this turret system. I could set my router bit to that depth there and then go down in a series of 4 or 5mm passes. I'm not entirely sure what the distance is between these, but you just keep spinning it round without having to change the setting on anything up here that you've locked in place. Now, just to run through all of that again on a smaller router, partly to demonstrate the process again but a little bit quicker, but secondly because I forgot that the plunge base had died on the other router, so we're using the smaller one instead. So adapter goes in like that, and then we put in the old threaded guide bush that is 30mm. I'm going to move the turret round until the depth stop is floating just above the second stop. Then we'll plunge it down to hit the piece of wood below, set this to 0 so that then the cutter is reading on 0 on the wood and this is reading on 0. Lift it up 8mm so that the scale moves up 8mm and the depth stop moves 8mm in unison. And then we'll move the turret round to the higher setting, therefore doing about half a pass to begin with. And then after doing that pass, we'll spin it round to the second setting to go from there. Right, there we go. One stopped groove that's coming in from the back of the cabinet and stopping before it blasts through the front. Obviously, this jig is able to do both sides of the cabinet by using each half of the jig. Unfortunately for me, in the next video, I need to demonstrate how I'm going to cut this by hand. Now, before we finish this episode, I'm going to quickly show you how we're going to cut the back rebate out on the router table. So to lay out this groove, I'm going to be using a marking gauge before even taking the first cut on the router table. Now, we know that the back panel is going to be 4mm thick, which is what we accounted for when we offset this back tail. So we'll set the gauge to 4mm and scribe that down the back of the cabinet on only the inside face. You don't need to do this on the outside because it's a rebate. And as for how far it's going in terms of the piece's thickness, I reckon let's make it about 10mm. That way, once the panel is inset within the rebate, we've still got plenty of meat there to get screws or panel pins in or whatever we want to fix that back panel in place. If you make the rebate too shallow, then you're going to really struggle to get fixings through it into the wood behind. So 10mm seems a sensible option. And of course, we're scribing that from the inside. Let me do this. So I'm going to use the same 10mm cutter to do this. You could go a little bit bigger if you wanted, but I wouldn't say go much smaller than that when rebating. You don't need a dedicated rebate cutter in order to cut rebates. Something like this will do just fine on a small rebate like we're doing today. So when it comes to rebating out the bottom corner of this component, we've got two axes that we need to get right. Firstly, the height of the cutter in order to establish this 10mm depth of cut we've just scribed on with the marking gauge. And secondly, we've got the offset of the fence to mark how far into the component we want the rebate to go. In this case, 4mm to fit the 4mm panel going into it. So firstly, I usually get the height of the cutter set. And to do this, you can get things like height gauges that bridge over the cutter, and then there's like a ruler depth stop thing that allows you to set the height of it from the datum surface below. I don't normally mess around with them. I just put the piece of wood up against the cutter where I can see that marking gauge line that I've scribed onto it, and then we just put the cutter up to that, and like that looks pretty bang on there. But to be honest, in this case, it doesn't matter if that rebate ends up at 9 or 11mm tall, because we'll just size the back panel to fit it anyway. So don't stress too much if you don't get it bang on. The depth of the rebate from the fence, however, we want to get pretty bang on because we're working to the fixed dimension of that 4mm thick plywood that we'll be adding to the back panel. So to do this, I just slide the fence up so it actually goes beyond the cutter. So now when the component goes past, it's actually going to completely miss that cutter. And then with each pass, we'll just move that fence back a tiny bit at a time, checking the fit of the plywood as we go until we get to our desired rebate size. And it's best to do this with a tester block, obviously, and bonus points for actually having a piece of plywood to test the fit. But for me, I'm too disorganized to have that 4mm piece of plywood already purchased, so I am just going to be measuring it very, very precisely. The other thing I'd strongly advise you do is get rid of this clear plastic guard and replace it with feather boards. These will not only protect your fingers from the cutter, but as you pass material through it, they'll provide pressure right around the cutting area, so you don't need your fingers there in order to do it. I absolutely love using these on router tables because it makes it so much easier, safer and accurate as well. And the amount of pressure is completely up to you. Like that's pretty good, but I might put just a tad more on, and I'll do that by just lowering it about 1mm or so. Yeah, like that's pretty good. You can also get feather boards that push in from the side as well, but the wider panel isn't going to allow us to do it in this instance. And for a tester block, it can make it difficult to move in and out by having pressure pushing both down and across like that. When I'm using this tester block, all I'm going to do is push it up, take a cut, and then bring it back like that. I'm not going to be going forward and then getting my finger in the front and pushing it back like that. It's just boop, boop, done. So there we go, test cut's done. I accidentally overdid it on this one and went to 5mm, but on this one, however, I managed to get it bang on, and that is now 10mm down and 4mm across. So I'll just check all my fences are locked in place, get rid of the old tester block, pop the cabinet underneath, and just make sure that I am indeed rebating the correct corner. So it should be the back inside. And then I need to reset the height of this featherboard because the thickness of the material has slightly changed. Don't want this moving whatsoever. That'll do me. Right, and there you go. That's how you use routers and a special jig and a router table in order to cut the groove and the rebate for the cabinets. In the next video, we're obviously going to be showing you the hand tool method of cutting the rebate and the groove. And in addition to that, I will be showing you how to square off the end of this stopped groove because the router has left us with a rounded edge. And ideally we want that to be nice and square in order to fit the tongue on the shelf at a later date. So if you're on my online school, you can scroll down on the page and you'll find that video. But if you're watching this on YouTube, then clicking the link below will take you to the hand tool method of this video. And while you're there, don't forget to press subscribe to the left-hand side of this video. I'll see you in the next one.